Hello everyone, welcome to this channel. My name is Ruben and today I want to give you an update on Joby Aviation. I will do a deep dive in this company. Last time I covered EHang, but Joby got my attention as well. And last month Joby Aviation completed its SPAC merger with Reinvent Technology Partners. The stock currently trades between 9 and 11 US dollars with a market capitalization of approximately 6 billion. But first, what is this company about?
I'm Joby, the founder of Joby Aviation. I'm here at our electric flight base near Big Sur, California. I've been dreaming about vertical takeoff and landing aircraft since I was a boy. In 1993, I realized that with electric propulsion, my dream could take flight. But at that time, lithium-ion batteries had not yet entered production. 15 years later, lithium batteries had evolved through multiple iterations driven by exploding demand for consumer electronics, and lithium nickel manganese cobalt oxide cells with good specific energy, specific power, and excellent lifetime were in development for the nascent electric vehicle industry. Against this backdrop, I founded Joby Aviation in 2009 with the goal of building an electric aircraft to replace ground transportation. An aircraft safe enough for your daily trips, quiet enough to land at your destination, and accessible to everyone. What I'm going to show you today is that aircraft. A few months ago, we shared a video of our aircraft taking off behind me. Today, we wanted to give another demonstration of just how quiet our aircraft is. This is a calibrated decibel meter, and over here behind me is our aircraft in hover. At 55 decibels, this is more than 1,000 times quieter than a helicopter taking off at 90 decibels. As you can see and hear, it is not just quiet quantitatively, but also qualitatively, with noise that blends into the background. It is not the low frequency whop-whop of a helicopter, which travels for miles and penetrates buildings, nor is it the high frequency whine of a drone. Our goal was to mimic the character of natural sounds like the wind or the ocean. We hope that all of you will have an opportunity to come watch our aircraft fly in person. Until then, I hope that this helped to demonstrate just how hard we have worked to make this an aircraft that will be welcomed into your community. Now let's go take a look. This is a sibling aircraft to the one you saw sitting behind Paul, and it has been our workhorse, having undergone hundreds and hundreds of test flights since 2019. It is all electric with 6 tilting propellers. That means that each of the propellers is able to tilt from vertical takeoff position forward to a cruise position. This allows the aircraft to take off vertically before transitioning to forward flight, like a conventional airplane supported by the wing. By the numbers, the aircraft has a normal cruise speed of 200 miles per hour, significantly faster than a helicopter, with a maximum range of 150 miles on a single charge. It has 5 seats, including a pilot in the front and 4 passengers sitting behind. And the all-electric powertrain delivers 0 operating emissions. The enabling breakthrough technology that makes all of this possible is distributed electric propulsion, a core part of my realization in 1993. My idea that electric motors are vastly simpler, more reliable, and more scalable. So rather than a large centrally located combustion or turbine engine, instead we can distribute electric motors across the aircraft and place them in locations that deliver the greatest aerodynamic benefit. The result is an aircraft that is safe, quiet, and affordable. Each of these 3 foundational pillars of the design, safety, acoustics, and economics, is enabled by distributed electric propulsion. Now let's unpack each of these in a bit more detail, starting with safety. Safety is the most important element of an aircraft, and it's always been our North Star. Distributed electric propulsion allows us to build high levels of redundancy into the aircraft. We have 6 independent propellers running off 4 independent battery packs. If for any reason we experience a failure with one of the propeller stations, we can simply power down the diagonal station and continue nominal flight. We've actually gone one step further and engineered additional redundancy into the aircraft to make even that scenario as unlikely as possible. Powering each of the 6 propellers on the aircraft are 2 redundant motors, and each motor is powered by its own inverter, and each inverter is powered by a separate battery pack. Electric propulsion has allowed us to radically rethink every system on the aircraft to make it safer, lighter, and more reliable. From our redundant electrically actuated control surfaces, you will notice that we have 6 rudder vaders and 4 ailerons, to our redundant sensing, redundant flight computers, and redundant communications, all designed and manufactured in-house. The bottom line is that there is protection upon protection, guided by our North Star of safety. I would like to point out the locations of our 4 battery packs. We purposefully placed them in the wings to keep them safely distanced from the passengers. We are now certifying our aircraft to prove to ourselves and the world that it is safe enough to fly everyone every day. Earlier, I touched on how hard we have worked to make our aircraft quiet. We believe that noise will largely define the success or failure of this industry. To be successful, we have to deliver customers as close to their destination as possible. This means regular flights in and out of built-up areas, which only works if the aircraft is really quiet. In addition to optimizing the aircraft design to be quiet in hover, we have designed it to be even quieter in cruise. The propellers spin at less than half the speed in cruise that they spin in hover. This means that the aircraft goes from quiet in hover to nearly silent in cruise. We've designed, built, and tested dozens of full-scale propeller designs over the years and modeled dozens more, capturing incremental learning and benefits along the way to get that natural sound profile that I mentioned earlier. This is one of the harder things to do in this sector. The last piece of the puzzle is making the aircraft efficient enough and cost-effective enough to operate so that we can make our service broadly affordable. Going all electric delivers massive savings in fuel cost relative to traditional aircraft. That's good for both the bottom line and for the environment. In addition, the simplicity of electric motors means significantly fewer moving parts, lower maintenance costs, and less downtime. We optimized the aircraft design for efficient operations. With a high wing and propellers, we have made it as convenient to get into and out of as an SUV, which minimizes the time spent loading and unloading the aircraft. Electric motors spin up and shut down in moments, saving many minutes on each flight. We designed the battery pack with fast charge capability to enable recharge while arriving passengers are unloaded and departing passengers are loaded. With the efficiency of our aircraft in hover and in cruise, we do not stress our battery cells, and they reward us with incredible cycle life. In the lab, we have demonstrated more than 10,000 representative flight cycles while retaining excellent performance. The fuel savings, lower maintenance costs, high utilization rates, high block speed, efficient operations, and low depreciation enabled by distributed electric propulsion result in very positive unit economics, which our CFO, Matt Field, will talk about a little later on. Our goal is to launch our service at the price of a taxi, with a virtuous cycle of technology improvements, increasing scale, increasing demand, and increasing utilization to drive the cost down over time to the cost of personal car ownership. Now let's go see how easy it is to pilot our aircraft in the flight simulator. Here we are in our flight test simulator. Behind me on the controls is Buddy Denham, one of our flight test pilots. Buddy was instrumental in the development of the unified control architecture employed on the F-35. Our aircraft is designed to be simple to operate, unlike the complex controls in a helicopter that require both your hands and your feet. We've invested a lot of effort and thought into designing unified controls for this aircraft. That means there is simply one directional controller, or inceptor, and one acceleration controller. When you have a chance to go on our simulator, you'll be able to see for yourself how simple the aircraft is for our pilots to control. With electric motors, you don't need to warm up the engines, just press a button and go. The left stick, or inceptor, controls the aircraft acceleration. The right stick controls our altitude, attitude, and direction. There are no rudder pedals for your feet, and if the pilot lets go entirely, the software is designed to keep the aircraft stable. If the pilot pushes the decelerate to hover shortcut button, the aircraft automatically brings itself into a hover over the target landing zone. What we're demonstrating here is that we've developed a system that makes the aircraft really easy to fly. If you try and do something unexpected, the system doesn't let that happen. By automatically managing various flight functions, we're able to materially reduce pilot workload, mitigate common failure scenarios, and leave the pilot free to focus on the mission. It has taken a tremendous amount of work from an incredible team to develop this system, but it is so vitally important to the overall safety of our operations and provides a great example of the advanced technologies and capabilities that we've been able to develop, test, and mature by being the first electric VTOL company.
Let's have a look at the aircraft. The ideas for an economically efficient and scalable aerial ride-sharing service based on the company's proprietary zero-emissions eVTOL aircraft. Well, to clarify, eVTOL stands for Electrical Vertical Takeoff and Landing, and the vehicle is being developed with a plus 150-minute flight time range, capable of reaching 200 miles per hour, carrying 4 passengers plus a pilot, so 5 people. Joby claims that the eVTOL option is 5 times faster than driving in major metros at an estimated 4 times cost per mile improvement compared to the traditional helicopters. And the technology here has been in development for 10 years with several patents, and a key distinction that the aircraft operates in relative silence during the flight and is more than 100 times quieter than a helicopter during takeoff. Press a button and get a flight. Joby believes it can solve several global challenges, including roadway congestion, while saving passengers time with a vision to eventually offer flights at a comparable price as ground transportation. So at scale, the passengers will be able to select a destination on a mobile app, initiating a process for ground rideshare transportation to the nearest skyport. And the Joby aircraft would then travel to the destination skyport with another rideshare car waiting for the final trip leg. This is an example of a mode choice scenario presented to the survey participants, and the question was which transportation modes do riders prefer, and they make a comparison between the personal vehicle, ride sharing and pooled ride sharing, and then compare that with Joby. While for the personal vehicle, the cost per passenger equals the cost to operate with a travel time of 60 minutes. For ride sharing, it's $60 with travel time of 69 minutes. And for pooled ride sharing, it's cheaper. It goes to $39, but you travel still a little bit longer, 72 minutes. And then they claim the following thing. For Joby, it's more expensive, $90, but you're going to save time on your travel. So first, you take the car, 10 minutes. You have 1.5 minutes of swapping time of switching vehicles to the Joby aircraft. You fly 14 minutes, and then you have 1 minute swapping time and 5 minutes walking equals 31.5 minutes, which is approximately half of the time that you save. The key point here for Joby is that the business is real, with the eVTOL aircraft already performing more than 1,000 test flights through a contract from the US Air Force under its Agility Prime program as a step towards commercial certification. The US Air Force may use the vehicle in on-base operations by next year for field testing, and one of the most important aspects of Joby's business is the intense regulatory backdrop of transporting passengers commercially. And on that point, Joby counts on a former co-chairman at the FAA as its internal head of government affairs, and the company plans to perform an FAA certification test flight by 2022 ahead of a 2024 commercial launch target. Joby is preparing for scaled manufacturing and has therefore partnered up with Toyota. Toyota is one of the largest automakers in the world and is also an investor and partner of Joby, most recently investing $394 million in Joby's Series C round. And as one of the lowest cost automakers today, Toyota brings substantial experience in manufacturing and automation and should allow Joby to scale up production substantially while maintaining low costs. It's worth mentioning that Joby acquired Uber Elevate, a subsidiary of Uber, which was previously targeting the same aerial ride-sharing market. Uber remains an investor in Joby and plans to leverage its ground transportation ride-sharing ecosystem to support marketing and demand for the Joby service launch. So this will de-risk demand generation because the Joby is likely to appear in the Uber app on a non-exclusive basis and vice versa.
Why did you pick Joby?
So Joby has the amazement of a little bit like your earlier thing of the Jetsons now become real, of moving urban transport from 2D to 3D. It's Uber meets Tesla in the air, and that can transform space, people's commutes, stop gridlock and have that not have the climate impact, and to do all of these things in a way that make cities healthier and more fun and more ability to get around. And so that kind of redefinition of transport, of networks, has been one of the things that I've actually been doing over the last 5 to 7 years. And so while I originally hadn't thought about the third dimension of space, I did actually, once I saw it, said, oh, this is a new network. And networks are how we transform our work, our experiences. And so this, networks, I understand.
So we've all imagined that Jetsonian future when we're stuck in traffic or we have a long trip ahead of us, but we're not quite there yet. And I wonder, is this realistic for 1 billion people? How does this scale? Does it really reinvent transportation or just augment transportation?
Well, I think reinvention is in part also augmentation. You'll of course still have ground cars. You'll be moving heavy things around. There'll probably even be, various forms on the passenger side. But the reinvention means that what previously was configured by geography, think about, the flight to the airport, or or the drive to the airport, or think about, kind of getting around things. Now, it's just literally the 3D of potentially getting there. And that, emphasizing people and the fact that moving people around is really key. So I think that kind of reinvention, it's the same kind of reinvention that when we start doing plane travel, of reinventing space, that all of a sudden now, across the Atlantic, across the Pacific, isn't so far away. The fact that you could live a little further out, and kind of make that work. All of those things are the kinds of reinvention. Then, of course, the climate change and because of the sharing model, the accessibility to everybody as part of it, as Paul was talking about.
So let's talk about that. The Uber plus Tesla in the air metaphor is so vivid. Is the pilot a Joby employee? Is it a contractor like an Uber driver is? And is that really the best labor model at this point? It's a company that's still not profitable.
Well, we have to actually get the service going. Joby is the first to have a G1 paper with the FAA, and the only eVTOL to have a G1 paper agreed on how certification will work. It's flown a prototype vehicle over 150 miles, over 1,000 test flights. So it's real. You can see it actually, in fact, flying. It's not a design. It actually has a pilot doing it. And so I think one of the things that I think we start with having a pilot in the vehicle, even before autonomous vehicles, to maximize safety and understood and learn from it, because a combination of, obviously, it's safety, and then ease and kind of a good impact. So I think the labor market will be fine. One of the things that Joby did is they actually figured out a fixed wing a certification. So it's a broad range of pilots who've been trained, who only need a little bit of an additional cert in order to be able to fly them.
So what about competition like Archer and Lilium? Well, firstly, Joby is one of the furthest along in the eVTOL race. The 3 eVTOL companies thus far are all projecting commercial launch by 2024. Archer, for example, estimates a similar commercialization date as Joby. In June, they unveiled a full-scale 2-seat autonomous prototype of its maker eVTOL aircraft at the Hawthorne Airport in California, and this striking aircraft will begin ground tests and flight tests later this year, with air taxi services slated to begin in LA and Miami in 2024. However, Archer is currently facing legal action by private competitor Whisk for potential IP infringement. Lilium also estimates commercialization in 2024, yet it is facing a number of hurdles, including a failed fundraising round, the destruction of one of its prototypes in a fire, and potential performance issues. While 3 former Lilium employees who spoke to Forbes on a condition of anonymity due to confidentiality agreements, they said that they and a number of their colleagues left over past year out of frustration over the management of the company by Weekend, who they say is over-controlling and has held to an unrealistic timeline in the face of development delays, pushback from its engineers, and a planning process that was throwing up red flags. So is Joby a better choice? A strength in Joby Aviation is its experienced management team that includes former executives from high-profiling corporations including Tesla, JetBlue Airways, Ford Motor Company, and Uber, and this lineup gives the company some immediate credibility on the strategy and potential for execution. One other thing that I love about the Joby RTP deal is the incentive structure for management. Joby has one of the better incentive structures for a SPAC with a 5-year lockups on its founder shares, so it's past commercialization start, as well as vesting triggers at prices from $12 to $50. So senior Joby management and large investors are also subject to similar lockup arrangements. The reason this incentive structure is so important is because you don't know for sure whether Joby's concept is going to work until 2024. So locking up these shares for 5 years is a major vote of confidence by both insiders and management. So if certification fails or something goes wrong, they could lose all their money invested. So they are incentivized to make sure Joby succeeds. Even though all 3 eVTOL SPACs project commercialization only in 2024, Joby is the only one with this kind of incentive structure. So what about Joby Aviation's valuation? Approaching the year 2022, the reality is that technology has advanced to the point where this solution is actually viable. And by this measure, I can believe that the demand is there, supporting a positive long-term growth outlook. With a timetable to begin commercial flights in 2024, targeting the LA metro area as an initial launch market, the company has issued a forecast to reach $2.05 billion in revenue by 2026, with 963 aircraft generating on average that year in 3 cities. Compared to the deal valuation of $4.5 billion enterprise value, Joby is priced at around 2.2 times forecasted revenues of $2.05 billion by 2026, 5 years from now. From an investor presentation released earlier this year, management notes that the 2026 EV to revenue multiple is consistent with comparable high growth emerging technology players as well as disruptive transportation peers. For example, Uber and Lyft currently both trade at around 2 times their consensus 2025 revenue estimate based on updated enterprise values. The comparison becomes even more compelling considering the EBITDA potential. Joby believes it can generate $824 million in adjusted EBITDA in 2026, implying a current EV to forecast EBITDA ratio at 5.6 times, a discount to Uber at 15 times and Lyft closer to 10 times based on 2025 consensus EBITDA. To be clear, these companies are not directly comparable with key differences in strategy, but it helps to draw a baseline for valuation. So if we were completely confident in the company's revenue and EBITDA forecast, a case can be made that shares of Joby are attractively priced with upside potential. That said, it's clear that 2026 is a long way ahead and a lot can happen between now and then. So investors need to look at Joby Aviation as a long-term opportunity. Let's have a look at the service unit economics at scale in 2026. The good news is that the unit level economics for the Joby vehicles appear reasonable. From an average fully loaded manufacturing cost of $1.3 million per aircraft by 2026, the company believes each vehicle can generate $2.2 million in revenue with a contribution margin of $1 million per year. So in other words, each eVTOL can pay for itself in 1.3 years as a payback period, depending on a baseline of operation metrics between passenger load factor, average flight path, and cruising speed. With some more conservative estimates, the payback period extends out to 2.2 years, which is still good. In other words, assuming each aircraft can do 40 flights per day, charging $3 per seat per mile with 2.3 paying passengers on average per flight, the eVTOL is profitable. The challenge I see here is just looking at the 2026 estimates comes down to the aggregate demand outlook and volume across all 963 aircraft forecast to be in operation. Clearly, there are high traffic routes where Joby air taxis can work best along with a group of early adapters that will be willing to pay an initial premium. On the other hand, I'm skeptical that all 963 aircraft will maintain the same load factor necessary to reach $2 billion in revenue that year to justify the current valuation. So what kind of opportunities and risks do I see for Joby Aviation? Let's start with the opportunities. Well, Joby is likely to be one of the first companies to commercialize an eVTOL in the United States, giving it the opportunity to build a competitive advantage. Joby has the potential to be one of these market leaders in the future. So you can think about air taxis and autonomous air flight. There will be an expansion to aerial tourism, cargo and flying ambulance, and the military as well. Also, there's improved battery capacity and flight range that may potentially disrupt the domestic airline market. Joby also has strong partnerships, including working with Uber and Toyota on manufacturing and demand generation. And lastly, Joby has one of the best incentive structures that locks management shares up until a certain performance goals or timelines are reached. I also see 10 risks for Joby Aviation. The first is gaining a regulatory approval is key for success, so you have to think about passing regulatory hurdles. Also, they have to prove that the vehicle is entirely safe. Safety is very important. CEO mentioned that. There's mass adoption of new form of air mobility. That's going to take time. There also needs to be like integration of urban air mobility into the existing transportation landscape. How about competition such as Volocopter, Lilium, Archer, and EHang? As seen with Uber and Lyft, the ride-hailing business model may not be as profitable as a result in decaying unit economics as more players join the skies. Demand may also not be as robust as projected. There could also be like delays of certifications, technical issues, and infrastructure challenges for Joby, and competition with urban ground mobility. You can think about a Hyperloop system. And lastly, in this whole process, stock offerings may cause shareholder dilution. For disclosure purposes, I don't own this stock. If you would want to buy Joby, maybe allocate 1% of your portfolio for this and look for the very long term, like 2030, 2025. And my question for you is, are you gonna buy Joby Aviation and why? Thank you everyone for watching this video. I really hope you enjoyed it and that you actually learned something, and see you on the next company.